Hey everyone, welcome back. Today's day 3 of my 30-day FAANG grind, and I'm solving 6 to 10 LeetCode problems daily, breaking each down on video and sharing with all of you on YouTube. I'm Divya, by the way. I've interned at Massachusetts Institute of Technology, where my area of focus was on machine learning and statistics. Currently, I am at top 0.3% on LeetCode globally, and like most of you, I'm also preparing for FAANG interviews. Yesterday, we tackled two-pointer, and today we are jumping into prefix and suffix-based problems, which is super common in arrays and strings, and a favorite theme in FAANG interviews. We will also sneak in a few sliding window refreshers to keep all those patterns sharp. Before I begin, if this helps you, please give it a like, share with someone who is preparing, and please hit that subscribe button so we can crack these interviews side by side. Let us go. So, this is problem number 4 for today. Leet code 560. Subarray sum equals k. What does this problem state? This problem says that we have been given an array and we have to return the count of subarray such that the sum of that subarray equates to k. Okay, let us go to the dashboard. Let us go to the dashboard and we'll try to investigate and solve this problem in an optimal manner. Mm. Okay, so we are at the dashboard. We have been given nums array and a target. Our objective is to return the count of subarray such that it sums to the given target k. Okay, before I even begin explaining you, let me tell you something. Let us talk about the brute force approach first. What could be the brute force approach? The brute force approach could be that we generate all the subarrays, compute their sum, and try to equate whether it is equivalent to k or not, and make a count and return that, correct? But that will take order of quadratic path because generating array is proportional to quadratic time complexity, okay? Now, before I begin explaining, let me, my bad, let me let me tell you something. Let us look at this picture. And let me be very honest with you. The entire solution, first of all, this entire problem is really interesting. Okay. And second of all, the entire crux and the entire essence of this problem lies in this diagram. So please pay attention to what I'm going to speak. This pink thing, this whatever this color is like, okay. So what is this? This has this displays the accumulated sum, okay, through the entire array. You can call it as the prefix sum, but I will prefer to call it current sum, okay? But although prefix sum is a more general term, I will stick with current sum. So this entire box that you can see, it reflects the current sum or the entire sum of the array starting from 0th index till the last index, okay? What does this green box represents and what does this blue box represent? We'll come to that. Let us look at a very simple arithmetic equation over here. We have current sum, all right, which is this box minus k, which is blue box. What will happen if I subtract this box from that box? What we will be left with? We will be left with just this green part, right? Which is nothing but b. B is the remaining part of the current sum, okay? Now, what will happen add if I subtract b on both the sides and add plus k on both the sides? In simple terms, I'm sending b here and sending k over there, okay? So let us look at this thing now pictorially. What is happening over there? This is my current sum. In my current sum, I am subtracting b. So what am I remaining with? I'm just remaining with blue box, right? And what is that blue box? That blue box is k. And what is this k? This k is this k, correct? Our objective. So I hope you understood what this diagram was trying to tell us, okay? And by the help of this diagram, specifically using this equation and how it relates with our answer, we'll try to approach the answer in an optimal manner, okay? Before I begin, there are two things that we need to have in mind. The first thing is that we will need a dictionary. Why? We'll see. And the second thing is we need to check the difference. Which difference? This difference, okay? Let me walk you through the solution and we'll see how it proceeds. Initially, I have initialized current sum to 0 and result is the value that I will return, which is also initialized to 0, okay? Let us look at this example. I am at index 0, okay? And this is my current dictionary, current state of dictionary, where I have already initialized 0 current sum with a count of value 1. Why did I do that? We'll see. Let us look at this part, okay? I'm at this index, I'm at 0 index. and my current sum will be increased from 0 to 1. Okay. Now, as the current sum increases, let us follow this equation. Okay. Current sum has been increased. Okay, good. And my bad. Okay. Let us look at this example. Okay. This part. Current sum is 1. Okay. And in this, I have subtracted 2 because case 2. What do I get? I get -1. I ask, hey, is -1 present in my dictionary? The answer is no, it is not. Cool. So what do? I accumulate the current sum. The current sum that I have accumulated now, I will publish it into my dictionary if it is not already there. But if the current sum is already present in dictionary, I will increase the count of it. Okay. Since we see that 1 as the current sum is not present in dictionary, I will add it 1 over here and I'll place its count to 1 because we have seen it one time. Perfect. Now I've increased my index to here, right? My current sum will increase by 1 and it will become 2. Let us come over here. 2 minus 2, correct? It will yield me 0. I ask, hey, is 0 present in dictionary? Now imagine what would have happened if we would not have placed this 0. Hmm? What would have happened? We would have definitely missed this part, right? Even though it is this is a which is giving me 2, we would have missed that part because this 0 was not present over there with a count of 1, correct? So this is a base case, kind of edge case that you must consider, that every time we have to initialize current sum with a integer and count with the value of 1. Now you may ask, hey, why is current sum initialized to 0? Just keep this rule in mind. Every time we have been given a problem of this nature, which we will encounter more today, what you do is this value, how is this determined? Just place k over here, okay, and subtract it with the maximum of k, which is just like k, right? And this will give me 0, okay? What is this maximum k? This maximum k is something that we need to find in our window, correct? What is k over here? 2. What is this maximum k? This is 2. What does 2 even mean? 2 means, hey, in our subarray window, we must have some 2, correct? So that is what I'm subtracting as the maximum from k, and it is giving me 0. And that is why I'm storing 0 over here, okay? So every time you encounter problem like this, just put 0 over here, and 0 is coming from there. Why? Because it is seeking in this window. It is thinking every time we will encounter the window first time, there is chance that it will nullify to 0 and we will not have 0 in the dictionary. So let us place 0 with a count of 1. Okay, cool. All right. So now I was there and I was at this point, right? At this index, let me change the color. I'm at this index and my value has increased to 2. I computed, I saw, hey, 0 is present and the count of 0 is 1. So let me increase my result by 1. And this current sum that I have accumulated, I will store it in the current sum dictionary because it is not present there. 2 with a count of 1. Now I will increment my pointer again. I will come back over here. This current sum will increase to 3. And using this equation, 3 minus 2, it will give me 1. I will ask, hey, is 1 present in the dictionary? And we can clearly see 1 is there and its count is 1, correct? I will increase the count of result by 1, which will make it 2. And then I'll place this value 3 in dictionary because it is not present over there. So 3 will go over there, right? And we'll return the answer as 2 because we will have activated and exhausted the entire array, correct? Let us see if 2 is an actual answer or not, okay? Yeah. So this is the first window or subarray, which will give me 2, correct? And this is the second subarray that will give me 2, correct? Can this give me 2? No, this will give me 3, right? Can this be a subarray? No, subarray must be contiguous, right? Will this equate to 2? No, it is just equating to 1, correct? So yeah, that was all there was to this problem. Specifically, pay attention to this diagram that I've drawn. And using this diagram only, I have circulated and populated every single thing in the dictionary, in these equations over here, and how this current sums and results has been populated. Okay. Let us come back to the code and we'll see how it has been conceptualized and we'll try to understand the actual solution. Okay. Initially, I declare the dictionary with this value. Why? I explained you earlier, and current sum of 0 and result 0. Result is something that we will return at the end. Then I'm iterating through the entire loop. Every single time I'm accumulating the current sum by adding the current value. Then I'm trying to find this remain difference, which is nothing but something above that we have done over here, right? Result is B actually, correct? If you look at the result is B, right? This one. and then I am trying to increase the value of result by looking at this is a Python thing, okay? I'm basically in this line, I'm basically looking at the dictionary and I'm asking, hey, if the value of remain is present in the dictionary, please fetch its value and increase the result by that value. But if remain is not present, then just add 0 to it, okay? Then once that is done, I will accumulate my current sum or the prefix sum in the dictionary and I will add it to the dictionary, right? This should be 0 and +1, okay? It says if current sum is present in the dictionary, then please increase its frequency by 1, okay? If current sum is not present in dictionary, as in its frequency will be 0, then just add 1 in its place, okay? And then at the end, I will oops. And then at the end, I will return the result, okay? So what is time complexity? Time complexity, as is pretty evident, we are just iterating through the entire loop here. So it will be bounded within linear time complexity and space complexity because of this dictionary, right? So space complexity is the order of n, and time complexity is also bounded within linear, okay? Let's go back to the LeetCode dashboard and we'll see how the solution is getting submitted and whether it is getting accepted or not. Fortunately, my solutions has been accepted, so I will just paste my code over here and I will run it. And as you can see, the solutions has been accepted. So yeah, that was all there was to this problem. It was indeed a really, really interesting problem. If I would have to emphasize one thing, just one thing regarding this problem, then it has to be this specific diagram. This one, how this has been manufactured and how everything came to be, okay? So yeah, that was all there was to this problem. If you have any doubts, please ask me in the comment. If you love this video, give it a like. See you in the next one. Bye-bye.